Well, good morning, everyone, and welcome to this webinar on Albedo, financial PV gains and project bankability. I am very glad to see today so many people that have joined from all over the world. Please keep introducing yourselves. So far, I've seen people from the UAE, from Zimbabwe, from Australia. There's a lot of Spaniards as well. And please keep sending and introducing yourselves to the chat. And I would like to introduce yourself to today's experts, the people that are going to be talking to you about Albedo, bifacial PV gain and bankability. As you know, bifacial PV panels and bifacial PV projects are going to be actually probably even more than 40% from to 2030 and beyond, because they have higher efficiency than normal PV panels, and you can actually take advantage of lower LCOE with them. So to talk about these matters, I'd like to introduce first and foremost Miguel. Please, could you unmute your microphone and introduce yourself today?
Sure, Helen. Thanks a lot. Good morning, afternoon, everyone. I'm Miguel Sanchez. I'm responsible for the EPC department for Europe in Jinko Power. We are the business unit focus in Jinko for the projects, IPP, etc. activities. And okay, I'm I'm the first for this presentation today. So I'm going to present the point of view of the developer. So as most of you maybe know, Jinko Power, the company I'm working in, is an IPP producer. So we are involved in development, finance, and after that, follow up the construction of the project until the COD, and we start operation with the operation of every project that we finalize. So
Excellent.
having said that,
sorry,
right.
Go on, Miguel.
Okay. Well, I don't know, Belém, if everyone.
The presentation we'll do later. We'll just do now a quick introduction, and then we'll move on to the presentation. So don't worry.
Sure.
So essentially, Jinko, project developer, but also, has part of the PV module manufacturers, you can see, and bifacial is a big part of the strategy there. Alvaro, next, please, could you introduce yourself?
Yes, sure. Thank you. Welcome, everybody. My name is Salvador Bahia, and I'm the general manager at 88 Renewables, which is a different company in the same group that 88 Insights. We are independent advisor and technical advisor and engineering firm. And well, I will focus my speech today on albedo measurement and albedo estimations. I'm happy to be here with you today.
Excellent, thank you very much. And last but certainly not least, Jörg, representing the money people. Could you introduce yourself?
Yes, sure. Hello, good morning and good afternoon, everybody. Welcome from my side as well. My name is Yokan. I'm heading Bankia's structured finance division. So out of my team, we cover basically project finance and asset finance transactions. As you can imagine, with all the things going on right now in Spain, our focus right now is certainly on financing renewable energy projects here in Spain. And later I think I will still cover this when it's my turn to talk, but maybe you know that we've been one of the first movers also in considering merchant and PPA financings of renewable energies here in Spain, and been doing this now for the last 2-3 years, and also like to talk a bit about albedo and bifacial PV projects, and so happy to talk to you in the next minutes.
Thank you very much, Jörg. Okay, so I'd like to ask Miguel to please unmute yourself, prepare your presentation, and whilst Miguel does that, just to tell people here in the audience, if you're new with us or you already know us, essentially the way that this structure will work is Miguel will give a presentation, then Alvaro, then Jörg, okay, and then we'll take questions. I see that you're very keen, you're already sending questions. Some of those will definitely be answered during the presentations. Please send your questions through the Q&A box at the bottom. Don't use the chat. The chat is for us, just to talk about ourselves, to introduce ourselves. But in the questions, in the Q&A box, we actually can manage the questions a lot better. So please do it that way. And yeah, just to let you know, we are filming, we're recording this session. You will have the recordings available, and also we will send you the materials so that you can review them as well. Miguel, you ready with your screen?
Sure.
You already have a question, we were already saying like, oh, Albedo is changing. How do I calculate it? Don't worry, we'll get to it. Indeed, Albedo is changing. As little as 2-3 years ago, bifacial panels were an absolute, innovation. Nobody really understood how that works. But luckily, there has been a lot of research behind it and many more projects. So we know a lot more now. Miguel, perfect. I can see your screen perfectly. So go right ahead.
All right. Thank you, Belén. Okay, just to introduce my presentation, the idea is not going in very detail for the technology, just an overview about what the bankability comes from, and also how we have to treat this kind of technology in order to make it make sense for the whole operation. So, yeah. Well, first of all, let's talk about the global market in highlights. So what I have included here is, yeah, let me move. Yeah. Sorry. Yeah. The evolution in the last 5 years about the technology, the PV market has been incredible. So what I'm saying, the cost has been dramatically reduced, and also the number of projects installed has grown 70%, around 70% over the last 5 years. And the future at this moment, with the policies here in Europe that the European Union is taking over, so we can be very optimistic in the future of this technology. And in this future, it's clear that bifacial technology is going to be a key. So the bifacial technology comes from the PERC model. Well, I think this is not the forum to go into detail, technical details about the characteristics of the material, but it's the passivated emitter rear contact. That is what PERC means as a new technology in order we can achieve a 0.5 to 1% increase of the efficiency of the cells. So this is with an increase of cost for the model around 1 to 2 cents of dollar cents if you compare with a classic monocrystalline model. That is the most commonly installed as of today. And for the manufacturers, the process to convert a monocrystalline model to a bifacial is really easy. It's not going to take much development in order to create a new manufacturing line for this. Is only an adaptation, an easy adaptation. The challenge that this kind of model they have at this moment is going to be linked with some bullet point. So first of all, I think is the letit, which is a loss of efficiency made by the increase of the temperature. Is let's say it's a mechanism that is going to be more developed at this moment because we don't have the knowledge where it comes from. But at this moment, we can be optimistic in order to be more familiar with this effect. So the quality control and the production methodology, it's a challenge as well in order to make it understandable for the whole market. I wanted to include some model tests and inspection, as this is a new technology. Is something quite well. At this moment, there are more projects already installed with this technology, but it's something is brand new. So these are the five more important rules and regulations in order to uh, keep in mind for the calculation warranties, how to treat this kind of models, which is something similar like the monocrystalline model, but just keep in mind the different treatment of this, the back side of the model, in order to how to calculate reflections, how to calculate at least what is the reality of the production at the back. Development with facils. So at least in my idea, we have to subdivide the treatment of these bifacial models in a development in 3 stages, which is the beginning, plan configuration, well, albedo analysis, of course, plan configuration, design of the plant. So with the albedo analysis, at least at this moment, one of these main irradiation databases, these are that all of us, SolarGIS, Metronorm, or the NASA dates, they can provide an estimated albedo from this at least from the TMY and the files. The thing is, at least this estimation, they have a lot of uncertainty. So it's going to be necessary from a point of view to be on site, taking the measurements in order to make sure that what is the reality in that with the characteristic of the soil. So at least I wanted to include some different numbers, the percentage of the albedo, if comparing with different types of soil. So it's going to be a key to try to take this technology where this technology is more interesting. And it depends on the soil, of course. Yeah, sorry. The plan configuration, at least is going to be something pretty similar like, as we usually calculate with PVCs, for example, or with whatever tool, the the production of the PV plant. So at least we have to keep in mind some consideration with the slightly reduction of the DC AC ratio. The ratio that we usually goes around 120, 130 is going to be slightly reduced. So in same, the GCR, the ground cover ratio is going to be slightly reduced again. To increase production, consider, well, albedo and site condition, that's the same that I was talking about 1 minute ago. So to increase electrical protection, so at least we have to keep in mind that the model is going to have a different budget and a different production. So those calculations for this electrical equipment, small electrical equipment, needs to be sure, secure, and well, and same. Consider that this is a slight difference for these streams, configuration, stream boxes, the rest of the elements of the installation. Project bankability. So at least the challenge for the bankability, and we can talk in more detail with George. So at least is the solar result, is the analysis of the albedo. That is something that Alvaro can explain in detail after my presentation. So the PR definition for these bifacial models versus the capacity test. So at least if you are familiar with this kind of calculation, you can see that PVCs, for example, is a tool, a bankable tool that at least is calculating all of this production with the bifacial as a classic model, so increasing the capacity of the model by just the classic side. So at least there are some consideration in order to how to take the control of the operation, how to understand the treatment of the production with these bifacial models. So the models quality tests and inspections, so at least and we need to make sure that the models can produce what they are ensuring, at least the manufacturers. We are a manufacturer, of course. Special consideration plan design that we were talking about, model efficiency. So keeping in mind the IEC 61700-24-2, that is commanded of this main contractor to cover production and equipment. So at least we still need a main contractor and EPC company at the back of all this operation. And it's a gap because at least as we were talking, PR definition, capacity test is not clear defined by the market at this moment. What is the methodology to move on about this kind of technology? And the operator after contractor for the warranty period. That's clear. One of these, the main challenge for the technology is good treatment of the operation, the maintenance for these models during the lifetime of the project. Having said that, so I'm going to the conclusion. At least it is clear that we have some challenge with the technology. That is something related that is a very brand new technology. So at least it needs to be more mature in order to make sure that all the mechanism during within the classical partners, classical parties for this technology for the whole operation are sure and are familiar with the technology. So at least we need to make sure that the albedo has been well considered. We need to make sure as well that the design configuration of the plant it's well considered, and we are taking the real optimal, at least with the manufacturing follow-up of the manufacturing process. And we need to make sure, and we need to be there checking that the models are correctly inspected, and also that the models are going to be okay from the quality point of view. Increasing production at least, reducing all CUE with a similar cost. And overall, at least what we are going to see in the next year is with this, with the level of the prices that the technology is taking, at least at this moment, from a point of view, there is going to make sense to manufacture only bifacial models in the next years, and at least the client will decide if they are going to use one side, both sides, whatever. But at least I don't see many difference about manufacturing that is going to make me decide or make me think that we are still being manufacturing mono during the many more years. And well, I wanted to include just an example. What is the repercussion on the delta with the different parameters of the plant? So considering soiling and albedo, how reflects that the PR and yield can be modified, can be moved. It depends on consideration. Just as an example. And that's all from my side. So just a brief presentation on what are the challenges to keep in mind at time to develop the project.
Thank you very much, Miguel. Thank you very much for this comprehensive presentation. I'm just gonna take your presentation off, and I'd like to invite Alvaro to introduce also to put your presentation up, sorry, to unmute your microphone. And we are actually having some technical issues with Jörg. We're trying to recover him. Hopefully this will be done. And yep, perfect. So we can see
my
that
presentation, Belén?
we can, yes. Miguel, there is a lot of questions open already. There are about 9. Maybe some of them you could be answering by text. If you could, I would really appreciate it, please.
Okay.
And Alvaro, go right ahead.
Yeah, okay, thank you. So I'm going to start with a very brief introduction about the company, about that ATA Renewables. As mentioned before, we are a technical advisory, independent advisory firm and engineering company working in renewables. We have worked in more than 50 countries. We have more than 70 engineers in the team. We have 5 offices in different continents. We have an accumulated experience that reaches 80 gigawatts and more than 500 projects already financed and successfully constructed. So the topic today is bifacial technology, and in particular bankability. Okay, so bifacial technology, in the end, it's similar to a conventional monofacial module, with the difference that it can also produce energy by converting into electricity the radiation that reaches the rear side. Okay, that's the only difference. But this difference makes implies a lot of concerns that should be taken into account when analyzing bankability, at least from the technical point of view, which is the one we are expert. Okay, so I listed here some of the main concerns or issues to be assessed for when analyzing a project. So basically, we are talking about a different technology. So we have to focus on the technology itself. It is a bifacial model, which is similar but not exactly the same that monofacial model. Then it is important the contracts, and in particular the warranties, how the performance warranty are defined in the contracts. This is extremely relevant because it is different to the case of a monofacial technology. And finally, Miguel already introduced this, the yield estimation. So doing a yield estimation for bifacial, it is a bit more complicated than for monofacial. And in addition, there is a lack of track record compared, obviously, with the conventional monofacial, where there are a lot of existing plants already in operation. The models are very well calibrated, and the accuracy of the methods of the advisor and the companies is quite good. In bifacial, we have this lack of real experience, and this means things a bit more complicated. Okay, and as part of the yield estimation, we have to properly estimate the albedo, the TNY for the albedo, because this is something that will influence a lot the result of the yield estimations. Okay, so this is what I'm going to focus today on, albedo TNY estimation. Okay. So albedo in the end can be defined as the ratio between the global horizontal irradiance that reaches an horizontal surface compared to the irradiance that would be reflected by a given surface, in this case, the terrain. So apparently, it's quite a simple thing. So it's just measuring the reflectivity of the terrain, right? But it is not the case. So albedo is not a constant value. It can change, and it has a lot of concerns that should be taken into account in order to properly assess and estimate the TNY. So I'm going to start with mentioning that with the fact that it is not a constant value. So the albedo can change during the year, from one month to other, from one day to other, and even within the same day there are changes in the albedo. Some of the reasons are pointed out here. First of all, because there are changes in the terrain, the vegetation can change during the year. Then the position of the sun. In the end, the amount of radiation that a given surface will reflect will depend on the incident and on the angle of incidence of this irradiation in the land. So therefore, if the position of the sun is different, the amount of radiation that the land will reflect will be different. And the same happens with the solar spectrum. depending on the kind of solar spectrum or the irradiance that is reaching the land, the amount of energy or radiation reflected will be different. Therefore, since these two parameters, the position of the sun and the solar spectrum, are varying continuously, the albedo that I could measure on a given point on different moments will also be different. Okay. Here is an example of data provided by a satellite data provider, which is NASA, just in order to illustrate how the albedo can change the monthly albedo during a whole year. Yeah? And then, but it is not only the only change. There is also an interannual variability, which means that even the same day or the same month in different years can, for a given site, could have different albedo values, which is a bit more complicated to understand, because in the end, the position of the sun will be similar, and the rest of conditions could be similar, but it is not the case. Why not? Well, maybe because there can be change, mainly because there can be change in the terrain due to climatic conditions, and secondly, because in the atmospheres, in the air, there can also be changes like the dust, pollution, and things like that will influence on the characteristics of the radiation that reaches the land. So in order to give you an idea of how this variability could be, in this graph, we illustrate the annual variability for annual albedo in different sites in different countries. So as you can see, it is not a negligible variability, but it is an important one. So once we have highlighted the fact that albedo is not easy to estimate and is not such simple, what are the possibilities we do have today in order to properly assess the albedo of a given site for a given project? So the first possibility would be using terrestrial databases like Metronome. However, the problem is that they are not recommended for this kind of assessment of albedo, because the albedo is very independent on the site itself, of the land and the terrain. So even though we have a meteo station which is located very near from our site, it may be the case that the terrain is not exactly the same, and the albedo differences can be very high. So they will not be accurate for doing albedo estimation. Then we have satellite databases. They provide quite reliable values, but still they have some inconvenience, I would say, which are mainly the spatial resolution they give you, the accuracy, the level of uncertainty that they are giving when using their estimation for albedo TNY. And the last way to approach this, it would be by carrying out all measurements on site. Okay, the only problem is that since we have said that albedo is continuously changing, in order to properly assess, we should make a long-term measurement campaign. Okay, so in the end, even though the satellite databases could be acceptable, in order to go further and provide something which is a bit, let's say, better or more accurate, why don't we make a mix? So this is the core of our method. Okay? So basically our method consists of going to a particular site when a client requires to perform an albedo estimation, carrying out a short-term measurement campaign which will last between 1 and 7 days normally, and then correct this data and make a correlation with long-term satellite database in order to provide a representative estimation of the long term. So the method itself is divided in 4 steps. The first step is obviously the measurement itself. There are some concerns to be considered. First one is the equipment. We need to use calibrated equipment and high accuracy equipment. Secondly is the duration. We have to define the duration of the campaign, the number of days, the number of hours per day, and also which hours during the day we will be measuring, because albedo will be changing during the whole day. And then we also have to define the measurement points. Here I put an example of a project, a big project with different colors, with different kind of lands. So before going there and measuring everywhere, we have to, from back office, we have to assess the site and properly define what will be our measurement point that will be more representative. Okay? And lastly, the climatic conditions. So we have to define the minimum condition that should be required in order to consider that a particular measurement is valid. Then after the measurement, we have to carry out that data processing, which is very simple and basically consists on cleaning measurement errors. And then there is an important step on the process before going to the extrapolation with the satellite database, which is the data correction. So the data correction is done in order to correct those effects that could have affected to our measurement, but would not be representative of the long terms. And I'm going to try to explain this with an example, which would be the rain in the precipitation. Okay. So if, for instance, I go for a particular site to do a measurement in August, and in this site, normally August is not a rainy month, but the specific year or the specific day in which I make the measurement, it happens that it has been raining for the last 3 weeks. The measurement that I will take will not be, let's say, representative of the long term, because it was affected by this unusual raining, which is not typical. So raining is one of the most important, it is not the only one, but this kind of effects has to be corrected in order to not to influence or make the measurement not representative. So after doing this correction, we can already proceed to extrapolation. And with extrapolation, there are also some concerns, mainly the database, which is the long-term satellite database to use. We have a lot of possibilities, and the extrapolation method itself. So this is the explanation of our method. Last year, we carried out an experiment that last the whole year, 2019, where we try to let's say validate our method. The experiment consisted on carrying out on a particular site. In this case, it was near Seville in Spain. We carry out a monthly measurement. Once a month, we went to the same site and we take Albedo measurements. You have the data recorded in the graph shown in the right side. And then once the 12 measurements had been taken, we start checking with different satellite databases for extrapolation and with different methods of extrapolation and with different corrections for precipitation, correcting by the last 3 weeks raining, by the last 1 week raining. So let's say that we check multiple variables aiming at identifying the method and the satellite database and the corrections that gave the best results. What is the one that gave the best results? So basically what we are looking for is the method that if I apply this method for a particular measurement, for instance, for the January measurement, and I make the whole extrapolation for the whole year, and I repeat the experiment for a different month, for instance, August, and I get the extrapolation for the whole year, ideally, both estimations should coincide. So no matter when I make the measurements, the estimation for the whole year should be the same, ideally. So this is not the case, but because there are some uncertainties, but let's say that the target was to identify the method that minimizes this difference. And this is what we did. And that is how we identified the best way to proceed. As that was how we define our method. And also we were able to measure the deviation, standard deviation of this method, resulted in 1.39, which let's say that compared to conventional satellite database, they could be in the range of 2.5. So it's significantly lower. So as conclusion, the Albedo TNY estimation, which is very relevant for bifacial projects bankability and for bifacial project defining, can be performed maintaining low uncertainty by combining satellite databases and short-term measurement. However, it is not a simple process and requires a lot of correction and a lot of assessments. We made publish 1 month ago, more or less, a full report, a Whitepaper that you can download in this link. And maybe Belen can put the link in the chat, or I will do it later. And also I include this graph in this map where I highlighted some of the sites where we have applied our method in the last year. And this is all from my side. Thank you.
Thank you very much, Alvaro. I had gone right ahead of you and actually shared the paper earlier. It's in the chat, you guys, so you can just click on the link and download it yourselves. And okay, Jorg, we've lost your image, but I think oh, now you're back. Yay! I think we can hear you. Can you switch on your mic? Let me see if I can do it. No, you have to do yourself. Hey, perfect. Okay, so your point of view, and especially as Alvaro was mentioning so much the bankability side of things, and this is a complicated matter to understand. A lot of questions about, okay, why does it change the Albedo? So your point of view about bifacials and all of this topic, please. I know you don't have a presentation, but go right ahead.
Okay, thank you. Yeah, you're right, Belen. I don't have a presentation, and obviously, I mean, from a bank's perspective, obviously there is little we can add from a pure technical perspective. So maybe let me just briefly explain how we look at projects which are presented to us and which from sponsors who wish to use bifacial PV modules. I mean, in general, as you may understand, I mean, obviously, any introduction of, let's say, new risks or new technological challenges to a project from a lender's perspective is always a challenge. And I mean, as you know, in the project financing, we heavily rely on the predictability of future cash flows, and that is how we can achieve to raise certain debt against the project and to achieve attractive leverages in the project. But again, this is a play of risk and reward in the end. So we have to see as a lender, if the risk that we run by generating these cash flows is still let's say assumable from a bank's perspective. And obviously the more aspects we introduce into a project, the more complicated it gets. Yeah. Now, having said all this, I mean, I think lenders are somehow in the world of energy and renewables. I think lenders are somehow familiar with taking on board to a certain degree technology risk, new technologies. I remember the time, for example, when we financed the first solar thermal power plants here in Spain, CSP technology, that at that time was also quite unknown, and there was quite a bit of also uncertainty, obviously, from a lender's perspective, if this is bankable or financeable on a long-term basis. And but in the end, I think we always found good solutions, let's say, to get these projects off the ground. And I think this is certainly what will also happen in the future with PV plants using bifacial modules. Maybe from our perspective, from my perspective, I think there are basically like three aspects or challenges that I see and that I would maybe like to briefly comment on. First of all, the technology risk as such. Then second, the production, the additional production that will come from this technology. And then also third aspect, which I maybe would like also hear what my co-panelists think about, how this will also impact then on a long-term basis in regards of operation and maintenance works on a PV plant. Maybe to run quickly through these three aspects, technology. Obviously, as a lender, we first of all have to get comfortable that these modules present the same level of reliability than what we would also expect from normal non-bifacial modules. That is certainly one aspect we would like to understand, and where we would certainly need to rely on the technical consultants that we typically use in the project finance transactions, like ATA, for example. And so that is obviously an important issue, that to get comfort that the PV modules will in the end present the same useful life than what we can expect also for a, let's say, normal non-bifacial module. Let's suppose, again, I'm not a technical expert, let's suppose that we can say, yes, it is the same useful life and so on. Then obviously the key question is, what do we do with this additional production that may come from using bifacial modules? And I mean, first of all, I would say, possibly the question is not if a project can be bankable or not bankable, if it uses a bifacial technology. I think we can use it possibly, as long as we get a positive opinion on the useful life, we can use it. But the question is obviously if you would like to, as a lender, to consider the additional production that comes from the bifacial technology in your base case or debt sizing model. That is obviously the question. And I mean, as you know, in a project financing, there are always, let's see, two big stakeholders. On the one hand, it's a lender, and then it's also the sponsor. And obviously, you can use the technology, but the question is who of the two is going to take the risk on this? Yeah, and it must not necessarily be the lender. It can also be the equity, or it can be both of the two parties. Yeah, I mean, there are certainly there's a certain variety of alternatives that I can see. For example, how to treat with this additional production. I can obviously, what we could do, for example, is just don't take it into consideration for doing the debt sizing exercise that is typically done from a lender's perspective. So any additional production coming from the bifacial technology would then be for the benefit of the sponsor, but he's then also taking the risk on this. So he will not achieve a higher leverage, but he would have the benefit of the higher cash flows that are generated eventually. A second maybe element that could be of interest is what I mentioned.
Is it just me or we've lost Jörg?
Mentioned before that some years ago when we did the CSP financing here in Spain, for example, where we had from the sponsors a production guarantee on board. So can you still hear? When we financed the CSP plants, we obviously we had a production guarantee on board from the sponsors. So the sponsors, what we agreed with the sponsors that we would finance these plants, but given that we didn't have the necessary comfort in the technology, we said that we wait for 1, 2, or 3 years, and then we look into the actual production of the plant. And if the production is not what we thought it would be, we would then do a readjustment in the base case and maybe somehow deleverage the project by additional equity or whatsoever, or just leave it as it is if the production values can be confirmed. Yeah, so that is certainly another technology that introduces obviously a guarantee element, but it's a possibility. Another would be maybe to design an additional debt tranche that can only be drawn down after, let's say, for example, 1 year, once you've seen that the plant is up and running and can produce the production levels that were expected. That is certainly another element. Or if you go to a more aggressive structure, would be that lenders would accept, let's say, to somehow consider the additional production, but then we need maybe certain, let's say, mitigating structures just in case that the production levels in the end cannot be achieved, like additional cash sweeps or whatsoever. Yeah. So for me, another question that I would maybe later pass on also to my colleagues here is also what you would consider as a reasonable time frame for, let's say, testing a power plant, let's say, under really full operating life conditions before really as a lender I can say, okay, that is now sufficient to take on the comfort. And then there is certainly a last aspect that I would also like to comment. It's not only about the technology as such and also the additional production risk, but I think we as lenders would also like to know what's going to happen, let's say, on a long-term basis from a pure, let's say, O&M perspective. I mean, obviously the Albedo depends on the ground conditions on the site. Yeah. So do we need, for example, additional obligations on behalf of the operator, let's say, to keep the site in a certain condition so that the Albedo is not affected on a long-term basis? All these things obviously somehow have also to be need to be considered, and someone has possibly to guarantee this. And again, I mean,
Same question again. Can you hear, Jörg?
I'm not as a technical expert here that we would feel certainly from a lender's perspective. So talking here about something which is completely, let's say, impossible. I hope that not so much was lost. No, I was
Okay, I'm not sure what's going on with Jorg. Unfortunately, I think he's got
maybe
stuck.
saying as a brief summary. I mean, obviously, I mean, assume from a lender's perspective or vertical, let's say, experience how reliable these additional production might be and the modules might be. And I think that a good idea anyway would be, so now I'm certainly lost again.
Yeah, no. We can hear you. I've taken your video off to see if the bandwidth means that we can hear you continuously. Okay, so just keep going. We can hear you.
Can you hear me?
Yes, we can. I've taken your screen off to see if the bandwidth will allow you to hear you better. Can you hear me, Jorg? Jorg, can you hear me? Okay, let me ask a few questions. And
can you hear me?
Yes, we can hear you.
No.
Okay, he cannot hear us, unfortunately. So we're just gonna go ahead and ask a few questions, if that's okay. It's a shame, really, because we've lost the most interesting part of the end.
Can you hear me?
Jorg, yes, we can hear you. I'm just not sure you can hear us. Okay.
My apologies for this, but it must be a internet issue I have here.
Don't worry. Can you hear us now? Can you finish what you were saying? Okay. So let me ask you a few questions, Miguel, Alvaro, if I may. Whilst let's see if we can get back Jorg. Can I just ask you, can you open up your microphones, please, both of you? Yeah. So, Alvaro, one very specific for you is the ATA method for measuring albedo applicable to any location around the world?
Yeah, sure. No, there is no problem. There is no difference. The only particularity is that we have to travel. Now, with the restriction, this is being difficult. In some countries, we have funds and local partners that can do the measurements campaign on representing ourselves. But yeah, we could do everywhere, provided that we don't have restriction for travel.
Okay, so here there is a question that has gotten me a little bit confused. It says, what is the truest software to get the bankability or to understand bankability from Iñaki? Is it PVCist or is there anywhere else? I think kind of the point that we were making is that the calculations that are currently available are not too strict, so to speak. So for bankability issues, we need to go above and beyond. But is what's the case? I don't know, Miguel, maybe let me ask you this question. As a developer, you know, for bifacial projects, what do you use in order to secure bankability for your bifacial projects?
It depends, at least. There is no just a specific tool for bankability or that is going to make the bankability working for the banks at the first view. So at least it's a process. It's going to consider. We use the same tools that for the monofacial models, but of course, including the methodology that Alvaro was talking about, and that is a procedure at least how to secure the calculation and how to secure what is going to be the production. So at least we use same tools, PVCs, as usually Solar GIS the revision database, but at least adapting and also considering that these specific parameters that I was talking about for the bifacials.
There is a question here about materials, and a lot of people asking, you know, have you tried different material textiles in different locations in the albedo, and how that affects the LCOE reliability, and even what would you recommend as materials for increasing albedo artificially? I just wanted to open this question. I imagine it's a cost opportunity calculation from, you know, what you gain and what you lose in terms of, so just to the two of you really, as a, you know, a technical advisor and as a developer, I mean, how would you approach this topic?
Yeah, from my side is exactly what you said, Belen. So first of all, you have to assure that the material you are evaluating will not have any kind of environmental problem. So you cannot install whatever on whatever site. You have to be sure that the material you want to install will not cause any kind of environmental problem or environmental concerns with the permitting of the project. Once this have been solved, it is just a commercial issue. So you have to take into consideration the cost and the benefits, how much the albedo will be increased and how much the energy will be increased and how much it costs. But also it is important to consider that normally this kind of material will not last for many years. So maybe you have to replace, you have to say maintain. So when you're analyzing the global, you have to consider not only the installation cost, but also the durability and the maintaining and replacing cost, if any.
Miguel, would you like to add anything here? And welcome back, Jorg. We can see you now. Hopefully we can hear you as well.
Yes, everything's fine. Really, my apologies for this, but I
no,
don't know.
Don't worry. Don't worry.
Quite weak. I don't know. Sorry for this.
Let's let just Miguel answer this specific question, and then you can finish, perhaps. Go on, Miguel.
Well, I don't have much more to add in addition to what Alvaro was saying. So
okay, that's fine. That's fine. You guys, this must be something like in terms of RPFs that are currently asking for bifacial modules. Do they specify the albedo in the RPF, in the RFP? Sorry. So in the tenders, do they specify how do the bifacial PV tenders are? Someone is asking here.
Well, based on my experience, there are not specific tenders for bifacial, so they are open tender to all technologies, and therefore you can find different cases. In some cases, the tender organizer gives you the yield, the solar, the TNY, the solar resource to be used for hypothesis to be used for the project. In some cases, it is the bidder who has to make its own calculations. But I never saw that in a particular tender they gave you albedo measurements or albedo estimation. It is the bidder who has to, in case that they want to bid with the bifacial, it is the bidder who has to make its own assumptions.
However, bifacial projects are winning more bids as time goes back. So, this is why.
This is changing it. It is a process. And so the fact, there are 2 points here. So the first one is the albedo. I mean, a bifacial project will be more attractive in desert than in a country with a lot of vegetation. So in Middle East, for instance, normally bifacial is the most competitive. And secondly, it is the price. So bifacial modules are a bit more expensive, but the gap is being reduced every month. So here is the miss. So normally they are winning in these big bids because the gap is being reduced, but also because in the Middle East, normally we have a very clear ground with high albedo values.
So sand is very good for albedo, guys. Write that one down. Okay, Jorg, let me give you, let's see if we get a few minutes with no problems from you, from the microphone. So, just give us your last, you would like on the last stretch. So it's been a little bit of a cut, but perhaps.
I don't know what was the last thing that you can hear. I think there was a bit of a let's say maybe summary also from my side. No, I mean, again,
just as a quick summary. Yeah.
I hope that I'm not repeating what I mentioned already. I mean, again, I don't think that let's say bifacial modules would not be, let's say, bankable. Let's say they certainly can. It's a technology that certainly can be bankable. But again, lenders need to get comfort. We need, let's say, to see projects that are really up and running with this technology and see how the experience is with the additional production. We need to get comfort with the technology as such, we would certainly not, let's say, just apply, let's say, the same financing technique, if you would like to call it like this, on a PV plant that uses bifacial models and a PV plant that does use non-bifacial models. Again, we would certainly need some sort of additional comfort to cover the technology risk involved and this additional production risk involved. And I've mentioned in my chat before some, let's say, some ideas that could be that we could think about. Again, it's a sort of balancing the risk between the sponsor and the lender, so that each one maybe can get what they're looking for in the end. Yeah, the sponsor certainly looking to try to get a bit more leverage by higher production. The lender would get to good comfort, and there are certainly let's say financing structures which can do that in the end. Everybody can get what he's looking for in a project, right?
Thank you very much. Yeah, definitely work with banks, right? That's, I think, in the end, and as more projects appear, then easier it's going to become. And having high quality equipment manufacturers also helps. So, okay, we don't have a lot of time, so I have here 3 questions, and I'm gonna kind of like boil them all into one, and I leave them up. I think it's more on the technical side, but I leave them up. So there is someone here that is asking, for example, how short can a measurement campaign can it be to be considered acceptable for you? So that's one. So how quickly can you make these measurements? Is Albedo higher on water or on land? And there is definitely this thing with floating projects. Are they good on Albedo? And the last one, if I wanted to increase Albedo, what are the ways to increase them now in the case of large-scale solar projects that are acceptable? So I leave this, maybe Alvaro, you take the lead, and then Jorg and Miguel can add whatever from their perspective.
Yeah, well, for the measurement campaign, in principle, 1 or 2 days would be enough. But the problem is that normally we make more days in order for big areas, in order to cover different kind of terrains, and so that we can make an estimation on the lowest scenario, the highest scenario, and the average. On the floating PV with bifacial, I don't know, Miguel, George, if you have heard about that in the past. In my opinion, this is something that is yet on a very initial stage, and they have no problem, but they have a lot of issues to demonstrate and to solve the floating PV, and they are like not thinking at this moment on bifacial. Ideally,
we had a webinar the other day, so that you know, and the person who was speaking about bifacials, they were saying that the future of bifacials are floating plants. So
yeah, but
let's take that into consideration.
It is like we are in the initial process. That's what I was trying to say, that and it is something new, and probably bifacial will have sense, but it's something that we'll start seeing in the future. I don't know if you agree with me, Miguel. Maybe you have seen already something in place.
Well, I didn't see yet. This is too new at this moment that I cannot say much more.
What was the last one, Belen?
We'll come back, in a few years. And there was what materials can you use? So what can you do to increase your albedo as of today? Like what has been done?
I think the most important, in order not to do it artificially using a different material, the best thing you can do is to properly maintain the site. So to clean it and cut the vegetation and so on. So this is essential. And in fact, I think this will be a key factor in the O&M contracts and during operational review of the PV plants to make sure that the operator are maintaining the land clean. If you want to use other materials, there are a lot of possibilities on the table. Some of them are impacted by local factors. For instance, if you have a closed site with white stones, apparently it could be a good solution to bring the white stones to your site. But if you have to bring them from a different countries, then it will be too costly. So some of them can be affected by the specific location, and some of them are general. But let's say that there is not a unique solution that is establishing itself as the best one right now.
Okay, well, thank you very much. Thank you very much, Miguel. Thank you very much, Alvaro. And thank you very much, Jorg, for all of your effort. I am so sorry this has been such a technical nightmare. I hope that you guys have learned as much as I have today about Albedo, about bankability, about bifacial PV gain. One thing I know is you cannot ignore this technology. It's coming to stay. It's coming with the strength. The projections look huge. And do we have all the answers today? We do not. However, as time goes by, we're learning hugely. And I think, honestly, in bifacial, I have been following it for a couple of years now, and I have seen the quickest gains in terms of innovation, because in these big tenders, in these big projects, we're literally fighting for pennies of pennies, cents of pennies. So in order to gain tenders, you need to get that competitive value very, very high. And this is the technology that is kind of increasingly been proven to be the one. So again, thank you very much, Miguel, Alvaro, and Jorg. And thank you very much to everyone. See you next time. See you in the next webinar. Thank you very much. Bye.
Thank you. Bye-bye.
Thank you, everybody. Bye-bye.
Thank you, everyone. Thanks.